So today we're going to talk about how to solve radical equations. So a radical equation is when you have a radical in an equation. Like any other type of equation, we need to be able to solve for x. Alright, so problem number 1, we have, what is the solution of 5 plus the square root of 3x plus 4 is equal to 10? Our first task is going to be to isolate the radical. That way we can take the square root of both sides to cancel out the radical. So, let us begin. So our first step is to isolate the radical. That means that we need to move the 5 to the other side of the equation. And we're going to do so by subtracting 5 from both sides. Our result is going to be the square root of 3x plus 4 is equal to 5. Then, once we get to this point, we need to take the square root of both sides of the equation. So, in order to get rid of the square root, it's always a good idea to square both sides. Okay, the square cancels out the square root. The logic behind it is when you use rational exponents, in order to cancel out the 1/2 rational exponent, you multiply it by 2. So we're going to get 3x plus 4 is equal to 5 squared. Simplify that. Get 3x plus 4 is equal to 25. Our last step is going to be to simplify in such a way that we isolate x. So, the 4 and the 3 have to be moved away from the x. We're going to first do so by subtracting 4 from both sides of the equation. And dividing both sides of the equation by 3. And our answer is x is equal to 7. For the second problem, we're going to follow the same principle. Okay? So for the next problem, we're going to follow the same process. We're going to subtract or add 5 to both sides of the equation, and then we'll square both sides, and lastly we're going to simplify. So this is the original problem. Now notice that the minus 5 is outside the radical, and you have to be careful to read that correctly. If it's outside the radical, it has to stay outside the radical. So first, we're going to add 5 to both sides of the equation. That is going to give us the square root of 4x plus 1 is equal to 5. Then, we're going to square both sides. Okay, the square and the square root cancel out, only getting 4x plus 1. And then we're going to get 25. Of course, the last step is to isolate x. So we're going to subtract 1 to both sides of the equation. And x is equal to 6. And we're done. Go ahead and try the practice problems if there are any. What we're going to do now is try to solve a radical equation that uses rational exponents. Now, rational exponents are exactly the same thing as radical equations. The only difference being is that we're going to use the properties of exponents to our advantage. But before we can do, always isolate the exponential expression. Just like you would isolate the radical expression. They mean exactly the same thing. So, we begin with 3x plus 1 to the power 2/3 is equal to 12. Then, first step is we need to isolate that radical exponent, that base. So we divide both sides by 3. 1 3 cancels out, only leaving x plus 1 to the power 2/3, while the other is equal to 4. Now, the next step is to take the inverse of the exponent on both sides of the equation. We're going to do so by looking at the exponent itself. We have an exponent of 2/3, and its inverse is going to be 3/2. We do so because we want to cancel out that power, okay? When you multiply them together by using the properties of powers, you're going to get 2/3, 3/2 times 2/3 is equal to 4 3/2. Now, you have to be careful about this because both of these have an even number, 2 and 2. Okay? That's very important because that 2, even though it's canceled out, it still affects the answer. And it actually changes to an absolute value, x plus 1. Absolute value of x plus 1 is equal to 4 to the power of 3/2. Okay? And of course, we also have to solve for the power 3/2. And we're going to do so by converting it back to a radical. We need to find the square root of 4 raised to the power of 3, which if you actually do the math is equal to 8. Now, since we have an absolute value, once we go to step number 3 where we solve for x, we have to consider the possibility that both it's negative and positive. And the way that we're going to do so is that the 8 is going to be split apart into two possibilities, plus 8 and negative 8. Okay, and we're going to set each one equal to the other. Let me erase that. Now, it's easier to change the 8 than it is to try to change the x plus 1. That's the reason why we did it. Okay, it still means the same thing. And when we solve, we get x is equal to 7 and x is equal to negative 9. Now, notice that we have two answers. And that's an interesting dilemma that we have over here because normally we wouldn't have two answers. But it's okay to have two answers. What you need to do is double check that both answers work. Because sometimes you'll get something called the extraneous solution. A solution that on paper looks like it works, but when you actually try to use it, it doesn't. So we're going to grab the original problem, which is 3x plus 1 2/3 is equal to 12, and we're going to begin plugging in each number. Now, the cube root of 8 is 2, squared is 4, gives you 12 and 12. So we know at least that 7 works. We have to do exactly the same with negative 9, see if we get the same answer. Look at this. Okay, when we plug it in, we get negative 8. The cube root of negative 8 is negative 2, but remember, we still need to square it, okay, which gives you 4, which also gives you 12. So negative 9 works as well. That's the reason why we have to use the absolute value in this case, okay? And it only happens when either m, the numerator, or the denominator is an even number. So even numbers always imply that you're going to use the absolute value. That's it for today. So please go ahead and complete the practice problems. Thank you, thank you, thank you.